There are two blocks as shown here, 10 kg block and 5 kg block stacked on top of each other placed on a surface. And the 10 kg block is pulled toward the right with a force F. And between the 5 kg and 10 kg block, there is a coefficient of friction of 0.2. The question is, what is the maximum force F max, with which we can pull the 10 kg block so that the 5 kg block does not slip away? Because we know that intuitively, if we keep pulling this 10 kg block to the right, beyond a certain force, the block at the top will slip away. But there is a maximum frictional force that is there between 10 kg and 5 kg block, which will hold it to the maximum. At that max frictional force, let's call that frictional force small f max, is when this block beyond which it will start slipping. So what is the capital F force, F max, beyond which this will start slipping is the question. Now let's draw the free body diagrams of these two blocks to understand them better. This is a 5 kg and 10 kg block. For the 5 kg block, it will be 50 Newton downward because G is 10 meter per second square. The reaction force will be 50 Newton upward. For the 10 kg, it will be 100 Newton because of the 10 kg block. Because the 5 kg pushes the 10 and further down this pushes it, there is 50 Newton from there. So the reaction force will be 150 Newtons for the 10 kg block. Now the small f max, which is the frictional force, is given by coefficient of friction times the reaction force. The coefficient of friction is 0.2 and the reaction force for the 5 kg block is 50 Newton. So this will be 10 Newton is the maximum frictional force. So at 10 Newton or beyond 10 Newton is when of friction force is when the block will start slipping. So let's consider the scenario at 10 Newton, so that at that point, whatever is the capital F, this force, that will be the answer to our question. So if this is 10 Newton, then the frictional force small f, according to the F equal to ma format, if we write, this will be 5 times the acceleration. Let's say this whole setup, the 10 kg plus 5 kg, moves to the right with an acceleration a. Then F equals ma, or the 5 kg block alone, if you consider, it is moving to the right with an acceleration a. So ma is on the right side, the left side is the force F. Now we know that the small force, friction force F, is 10 Newton. So this gives 10 equals 5a, or rather the acceleration will be 2 meter per second square if we focus only on the 5 kg block. But this is not slipping, which means the entire 10 plus 5 is also moving at the same acceleration, 2 meter per second square, which means 10 plus 5, 15 kg is moving at an acceleration 2 meter per second square. So again, F equals ma format, the force here we are talking about is the capital F force. So this gives capital F is 15 times 2 or 30 Newton. So 30 Newton is the maximum force which we can pull the 10 kg block without the 5 kg block slipping away.